we call them methods for preparations of alcohols. So we did it, and it was so interesting about it. Now we are having other part in alcohol. We want to know the chemical properties of alcohols. If now we are talking about chemical properties of alcohol, means we are just looking for the reactions that are taking place when alcohol is gained together or is jammed together with other substances or chemicals. So that is all about it, looking for the chemical properties of alcohols. Kwa hiyo chemical properties is all about checking out ni namna gani alcohol inaungana na nini kutengeneza nini. Hiyo ndio chemical properties ya hizi chemicals tunaposema namna hiyo tunavicheck. Now one of the factor or one of the reactions is called combustion of alcohol. Means addition with oxygen of alcohols. Now alcohol, like other organic compounds, burn in air to give carbon dioxide and water. Any organic compounds, when it reacts with the oxygen, as what we call it combustion, or when it burns in your presence of oxygen, that is called combustion. And the result must be carbon dioxide and water. Carbon dioxide and the water. That's why alcohol, like other organic compounds, burn in air to give carbon dioxide and water. So this is something common. Any organic compound, when burns in oxygen, in air, in presence of oxygen, the result is carbon dioxide and water. That is definitely something that you have understood. You have to understand. Example, ethanol. When you burn ethanol, the result is carbon dioxide and water. Whether you are burning propanoic acid, the result is carbon dioxide and water. Whether you are burning ethyl ethanoate, the result is carbon dioxide and water. Any organic compound, when you burn it in air, the result is carbon dioxide and water. That is not something difficult. Now the second reaction is called the reaction with metals. Reaction with metals means the reaction between alcohol and metals can be defined in such kind of the way that when sodium reacts with ethanol to give sodium ethoxides and hydrogen gas, means that if this is sodium and this is what we call it alcohol, remember this sodium will attack at the functional group, and the functional group of alcohol is OH group. Remember, when you are discussing about the reaction between alcohol and other things, you are talking about the functional group, because the functional group is the only part which is very reactive, or in other words, we call it the reactive part of an organic compound. And therefore, this sodium will come and attack this functional group so as to remove this hydrogen, so as it remains as a free, this one, it is as a free gas, which is light here. Then this hydrogen is replaced by sodium to form this, what we call it, ethoxides. This is called ethoxide. It is sodium ethoxide, means it is sodium with oxide of ethyl. So this is very important for us to understand when the reaction that is happening between alcohol and a metal. What we attack, the metal attacks at the functional group, and the functional group of alcohol is OH. Then, if that is the case, this hydrogen is removed, and then sodium is replaced instead of hydrogen, and this hydrogen is left alone as it what we call it a free gas as hydrogen gas. So this is the reaction between sodium metal or other metal. Even if now the reaction is between, maybe we are just talking about other metal, only the result is that this hydrogen will be replaced by that metal, because OH is the only functional group that exists in between this one. Now the other reaction of alcohol is the dehydration of alcohols to form alkenes. Dehydration means removal of water, removal of water means that you are removing water so as you may form what we call it alkenes. And this is done under this what we call it concentrated sulfuric acid at 170 degrees Celsius as a temperature. Now this reaction requires sulfuric acid at this temperature. If now you have reached at this 170 degrees Celsius and this concentrated sulfuric acid, this alcohol turns into alkane, means water is given off. That is why we call it dehydration of alcohol to form alkanes. In other words, it is the removal of water from alcohol. How does it happen? Remember, this is how we have written. This is the ethanol to produce ethane and water as a byproduct or side product when we are just removing water from alcohol. Example, when you look at this one, means this is C2, this is the H. Now this is the C2, then this is the OH. This, when you look at this one bond is made up of 2 electrons. And one bond is made up of 2 electrons. Now, these electrons, one of the electrons will be transferred to here, and here one of the electrons will be transferred to here. So 2 electrons will be formed here. Then this one electron will be transferred here, and this another electron will be transferred here. And to show that electron have been transferred to this point, we show by half arrow to determine that this electron have been transferred and it is half of them. Now we are having 1 electron and 1 electron. The combination of this one and this one, this is water. This is water liquid, which is right here. Then this electron and this electron get together to form bond, and therefore this we are having double bond, and double bond in case now we are just talking about the alkene, that is ethane. Now dehydration of alcohol, we form what we call it alkene. But this dehydration must be done under the condition that the temperature must be reached at 170 degrees Celsius under this condition of sulfuric acid. Now it's just like a reaction between alcohol and sulfuric acid under 170 degrees Celsius as a temperature for the reaction. If it won't reach, if it can't reach at this temperature, this reaction cannot happen. It must happen at this temperature. So this is the condition for the reaction, means it is a condition for dehydration of alcohol to form alkene. And this is one of the methods that is used to prepare alkenes from alcohol. And then the first reaction here is reaction with carboxylic esters. Now, when alcohol is reacting together with carboxylic acid, the only product that is formed is sweety smelling compound, which is called esters. Now, esters is only formed when there is a reaction between alcohol and carboxylic acid. So once you've been told to find esters, how this ester can be formed? Ester is formed after the combination of alcohols and carboxylic acid together to form what we call it ester. And the process is called esterification. Esterification. Now, the process in which ester is formed is called esterification. Means what? Esterification, the reaction between carboxylic acid and alcohols to form esters. That is called esterification. Now, once alcohols and carboxylic acid are getting together, they form what we call it ester. And the process is called esterification. Esterification. So esterification is another reaction that happens when the carboxylic acid and alcohols get together to form what we call it ester. Now let us see how does it happen. If now you are having this one, this is ethanol, which is an alcohol, and this is ethanoic acid, this is a carboxylic acid, and a concentrated sulfuric acid. What forms it is what we call it ethyl ethanoates. How does it happen? If this is now a case, we are having this one. We are having, this is it. Here it is. This is it. Then plus. Therefore, we are having this one. Then we are having this one. In this case, we are just removing water, just like dehydrations. Now, this will get together with this one to form what we call it water, because water liquid is a combination of hydrogen and hydroxide to form water liquid, and therefore this is what forms. Therefore, after we have removed this one, this gets together to form what we have written here. And this can be written in short. It is CH3, then it is C double O, then we have CH2, then we have CH3. This is the same thing. But once you want to show it with expanded structural formula. This is how we like it. Now, this is called esterification. Means this is a combination between ethanol and the ethanoic acid under the condition of concentrated sulfuric acid to form what we call it ester, and this is what we call it ester, ethyl ethanoates. Therefore, the last one here, is called oxidations of alcohols. Oxidation of alcohols. Now, the oxidation of alcohol and acidified potassium dichromate and acidified potassium dichromate, this alcohol oxidize, especially primary alcohol, we say acidified potassium dichromate 6 oxidizes primary alcohols to form carboxylic acid via aldehyde. Means there must be first of all, that alcohol is being oxidized to form what we call it aldehydes. And this aldehyde is being oxidized to form what we call it carboxylic acid. That is what I've written here. This is ethanol, and which is an alcohol. Then once it undergoes oxidation, it forms. And this bracket shows this is oxidation. It is quite different from this is burning. This is burning, but this means this is oxidation. And this is done and acidified potassium dichromate to form what we call it ethanol. And ethanol, that is aldehydes. So this is an intermediate product that is formed when you are just doing oxidation. You are conducting oxidation to alcohol. This is an intermediate product that is formed, and then this is oxidized to form what we call it carboxylic acid. Now this is carboxylic, and when you look at this carboxylic acid and the original alcohol, number of carbons are the same. There is no difference between the number of carbons, and that is why this now is oxidized to form what we call it ethanol, that is aldehyde, that is an intermediate product before you get into the carboxylic acid, that is ethanoic acid. Now, by doing so, we are having 5 reactions in which now alcohol must undergo to form other products. One of them, we have combustion of alcohols that I've said. When alcohol is combusted, we only expect it to form what we call it carbon dioxide and what we call it water. That is what I've said. Alcohol, like other organic compounds, burn in the air to give carbon dioxide and water. But also we have seen reaction with the metals. The reaction between alcohol and metals, what difference we are looking, we're just looking for a salt. The salt is formed, that is the example, the reaction between the sodium react with ethanol to give sodium ethoxide and hydrogen gas. Means hydrogen, after this metal attacks to the functional group so as to remove hydrogen, and so as this hydrogen remain as a free hydrogen gas, and this is replaced by the metal to form sodium ethyl oxides. This is the sodium ethoxide and hydrogen gas. And the third thing we have seen here, it is removal of water from the alcohol, and that is what we call it dehydrations of alcohol to form alkene. And I said this is one of the methods that is used to prepare alkenes when you are just talking about alkenes, and that I've shown the detail. And this is done under concentrated sulfuric acid at 100 degrees Celsius. That is the temperature that is required to be there so that the dehydration of the alcohol may take place. And also we are having reaction with carboxylic acid. Means when alcohol and carboxylic acid get together, they form the compound which is sweet smelling compound that is called esters. and the reaction is called esterification. So that is the reaction between alcohol and carboxylic acid to form ester. This reaction is called the esterification. And the detail of it, I've shown it there. And then the last one, we call it oxidation of alcohol. This acidified potassium dichromate 6 oxidizes primary alcohol to form carboxylic acid via aldehyde. Means aldehyde is an intermediate product that is formed once the alcohol is oxidized for the first time. So we are having the first step and the second step. So we have two steps on which now we can oxidize what we call alcohol to reach the carboxylic acid. Example I've shown here what we call it ethanol, that is an alcohol being oxidized under acidified potassium dichromate 6 to form ethanol, that is aldehyde, as an intermediate product before we reach the carboxylic acid, that is ethanoic acid, as the end product, as a major product. So in organic chemistry, we are having something major products and minor products. So we are not interested in minor products. Example, when you look at this one, you find this is a minor product or it is a byproduct. And once you look at this also, this is a minor product. It is removed. What we are interested is with only the major products. That is it. This is the major product that is my interest. So that is the end of all about chemical properties of alcohol. How do they react with other substances or other chemicals? And that is all about it.